The first problem is nothing more than the definition of functions. They defined these two functions here. And then they asked you to evaluate this, which we will do. And they even kindly told you what x to use. So let's just blindly follow what they said. So it's 3 times f of x, which is sine x. But they told you what x is. It's pi over 6. Okay, plus g. What is g? It's secant of x. But they said to do 4x. Okay, so I will do 4x. But what is x? It's pi over 6. Okay. 3 times sine of pi over 6. This is 30 degrees. If you don't know this, if you got to look up, if you have to use the calculator, you're in trouble. You should know all these famous 30, 60, 45, 90, and so on by heart. If you don't, you will not do well. All the way to calculus. Now, secant of, what is secant anyway? Nobody memorized secant values. Secant, as soon as you see it, you got to turn that into what they are. It's cosine, 1 over cosine, that is. And then you got to multiply this out, and what do you get? This would be 3, and you get 2 pi over 3. Okay, so we got the first part, we got 3 over 2, plus the second part, we got 1 over cosine of 2 pi over 3. Where is that anyway? So let's draw a unit circle to quickly to find this. So 2 pi over 3 is what? This is 180. So if you divide by 3, is 6. So it's 120 degrees. So it's here. In other words, this was 60. So I'm taking cosine of it. So here would be negative half. So this is negative half, which means it's going to be negative 2 when it goes to upstairs, right? I'm running out of room, so I will write it here. So we got 3 over 2 minus 2. So what do you get? We should get negative, this is 4 over 2, right? So it's negative 1 over 2 is the answer. If S denotes the length of the arc of a circle of radius r subtended by a central angle theta, so this is the situation here. We got this arc, which is S. It's denoted r subtended by a central angle. Central angle would be at the center of the circle. So this is what subtended arc is all about. And here's an angle, which is theta. The radius is r, and S is 5 feet. R is 30 feet. So this was a very small angle. I drew it out of scale, but that's okay. So R is 30 feet. Fortunately, they have the same unit. So I'm going to omit it because they will be divided. So express your angle to nearest second. Well, what's the definition of radian? Do you know radian's definition? Radian is arc length. Divide by radius. So 1 radian means you have an arc that if the radius is r, and if the arc length is also r, then the central angle here is 1 radian. Amazingly, many students don't know what 1 radian is because they're so used to getting pi over 6 radian, pi over 2 radian. So when pi is missing, they get lost. But this is it. Look up your textbook, and this is what it says right when it started. Okay, so 1 radian is arc length over radius. Okay, so shall we find arc length? They told you it's 5. What is the radius? 30. Aha. Okay, so that's the answer. The answer is 1 over 6 radian. But they told you to express this angle to nearest second. So this 1 over 6 radian has to be converted into degrees, which is done by multiplying 180 over pi, because 180 is degrees and pi is radian, and they're equivalent. So this is 1. So this is a fancy way of multiplying by 1. Okay, I trust you know how to figure out to the nearest second. This is an ancient way of measuring an angle using minutes and seconds. It goes all the way back to Babylonians. They used base 60 numbers. But amazingly, even today, in the most advanced telescope, the Hubble telescope still uses minutes and seconds. So what I'm saying is, don't complain, figure out this angle. For this problem, let's get some visuals here. So draw, roughly, -5 and 12. So here's the point here, and they're asking you to find the angle, theta, secant of the angle. So first you got to draw this line here, and then find out where the angle theta is. If you draw angle theta here, you're making a very common mistake. This is not the central angle. Angle has to be always measured from positive x-axis, always, no exceptions. Okay, so that is the angle we are talking about. But they are not asking for the angle. They're asking for the secant. So therefore, we don't have to find what the angle is. Because secant, well, any trigonometric functions is defined by the ratio of sides. And we got all the sides here. So we don't need to go to the angle. You solve this without ever knowing what the angle is. Angle was. Now, if I draw this auxiliary line here, this would be 12. And this is length is 5. So what is this hypotenuse? You have to know 5, 12, 13 by heart. If you need to compute this, you are slow and you will never do well on this topic. So commit all those trigonometry, Pythagorean triples to your memory. 3, 4, 5, 5, 12, 12, 13, and so on. Okay, now what I wanted to do was find out the secant, but nobody ever finds secant. I don't know what secants are. It's 1 over cosine. So I will find what cosine is. Cosine is so katoa, right? It's ka. Cosine is opposite, the adjacent over hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Adjacent is 5. So I'm doing adjacent over hypotenuse. It's 13. But I'm in the second quadrant. So you should realize the cosine is the x-axis value, and I'm reading negative here. So therefore, this is negative. That's it. So this is negative 13 over 5. Let's find the exact value of this. This is nothing more than substitution and finding the value. So it's quite simple. So let's do 3 times cosine of 5 pi over 3. Where is 5 pi over 3? It's the burning question. You got to quickly realize this is 6 pi over 3 minus 1 pi over 3. In other words, this is full circle minus pi over 3. So it is here. So this is 6 pi over 3. And this is 1 pi over 3. This is 60 degrees. And we are looking for cosine. Cosine is x-axis projection. So this is half, right? So you got to realize this is 30, 60, 90 triangle. And we are talking about the base here. So it's half. Plus, by the way, you learned the all students take calculus, right? Here, all angles are positive. Here, sine is positive. Tangent is positive. There's only sine is positive. Only tangent is positive. And only cosine is positive. So here I'm talking about cosine here. So it is positive, half. Okay, and then 5 times. And then 5 times sine of 5 pi over 6. Where is that? You should realize that's 6 pi over 6 minus 1 pi over 6. Okay, so where is it? It is 6 pi over 6 is 180 degrees. It's here. So it's 1 short. It's here. So that's the angle we are talking about. This is 5 pi over 6. And this is 1 pi over 6. In other words, it's 30 degrees. And we are finding sine there. So this, if I amplify that view here, this is 30 degrees. Here's 60 degrees. So if you are looking for sine here, this is half because it's 1 root 3 to a ratio, right? And this is the second quadrant where sine is positive. Or you can just see the y-axis. Y-axis is sine value. It is positive. It's above the water. So it is half. After this, this becomes a 4th degree problem. 4th grader's problem. So it's 8 over 2. So the answer is 4. all these are rather easy problems, and there should not have been any confusion. They are very straightforward. They're asking you to evaluate, just plug in and find out. There's no room for any confusion here. But I sense that the students' weaknesses are the basic is lacking. That is, do you know sine, cosine, tangent of, say, if I gave this here, and then I give you 0, 15, 30, 45, 60, 75, and 90. Can you randomly fill in, when I say plug in here, 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 would you be able to do that? Or do you have to look up? If you have to look up, you will never do well on this topic because you're just taking too long to think. That's equivalent to somebody who's talking while looking up the dictionary. They will never deliver a fluent speech. No way. Doesn't matter how smart they are. You need to carry the vocabulary in your head. So if you're postponing memorizing this, it's time to do it now. Without this, you will never make it in this topic. Second is understanding the quadrant business here. So as I told you before, is all students take calculus, but it takes more than that. That's actually dumb to memorize it because this sine and cosine business is all intricately tied to the x-axis and y-axis. You got to get the concept of projection. So if you have an angle that goes like that, and you got to see where it goes. A is positive. If you go here, it's negative. What does that tell you? Sine is positive, cosine is negative. If you divide those, you get negative. That means tangent is negative, and so on. So the unit circle has to be intimately close, intimately clear, and intimately understood by the student. For example, if I ask you to find the sine of, for example, 120 degrees, quickly you got to see, nobody finds sine of 120. They all think of this 60 here. Then you work on this here, and sine is still positive, and so on. So there's a reason I only ask for this first quadrant. The rest are found by flipping. If it's 120, you got to find where this is. If I gave you some angle like that, then you quickly find this angle and figure out. If I gave you an angle that is this big, then you figure out this angle to figure out the sine, cosine, tangent. And then you adjust the sign, S-I-G-N, accordingly by looking at the projections that I just showed you. So this mental gymnastics is the basics of this topic. This has to be completely clear and should require no second thought, equivalent to not needing to look up a dictionary to say good morning to somebody. Only then you can solve all these problems easily. If you're just putting this off and struggling with calculator and thinking that I made a mistake and such, you would never do well on this.